once you've got the brain exposed, you can do anything you want to the brain, and the brain won't particularly complain. I don't suggest you try this, but you could. Now, why? Well, let's step back. Why have pain receptors at all? What's pain good for? Yeah. Okay.
Pain receptors are very helpful, like being on a hot stove or something.
Yeah, pain's there to keep you from hurting yourself. You know, if you don't have pain and your hand's on the hot stove, you say, "Oh, I'm cooking my hand." That's, big deal. In fact, there are rare cases of people who are congenitally insensitive to pain, and it's bad news. They end up injuring themselves. That being the case, why not have pain receptors in your brain? Yeah. Yeah. By the time, if you sort of thinking sort of evolutionary terms, by the time the bear is chewing on your brain, you might as well just kind of go with the experience, because it's not gonna matter much. So the advantage here is that you can go in and stimulate brain tissue, and it's not a it's a somewhat, from the sound of it, somewhat uncanny experience, but it's not an unpleasant experience. And so, all right, so what Penfield did, stick a little electrode, say here, and put a little electrical current there, and what the patient would report, if it was here, this is to the parietal side of this big central sulcus, what the patient would report is, I feel it feels like you're touching my foot. Okay, move the electrode a little bit. Now it feels like you're sort of touching me in the middle of my back. Now it feels like you're touching my hand. No, it's the end of my nose. And what Penfield found was that the surface of the body was laid out across the surface of the brain. In the left hemisphere, it would actually be the surface of the right side of the body. Whoosh. I don't know what that is. And it is feet up, head down, as I recall. But that chunk of brain, which is called somatosensory cortex, the term's on the handout somewhere, represents the sensations coming from the skin. Now, I haven't drawn a terribly realistic picture here, but the actual map is hugely distorted. Yes, is something... Okay. I'll do that. Pay no attention to the man behind the curtain. Anyway, okay, so this map, known as the homunculus, for the little man in the head, the sensory homunculus specifically, is massively distorted. Some chunks of your skin are heavily overrepresented in the brain. Some are heavily underrepresented. So what's overrepresented? Hands and face, and on the face, lips and tongue and things like that. So somewhere in Gleitman, I'm like in the chapter you'll read tonight with luck, there's a picture. People love making little models of the homunculus, right? So to project it back out into the world, and what would it look like if this was a one-for-one mapping, and you get this guy with, huge lips and huge hands and a little tiny back. And the way to get a feeling for this is to ask yourself, if you were trying to figure out what something felt like, how would you go about doing that? Well, you would go and explore it with your hands. A little kid, less restrained than you, would also probably put it in its mouth and feel it that way. What you wouldn't do is, rub it against your back or something like that, because it's the hands and the lips and stuff that have the very dense sensory skin receptors, and it's sparser on your back. Now, you will also you can test the prudery of your introductory psych text by checking out whether the homunculus is anatomically correct. The genitalia are well represented in the sensory homunculus also. My recollection is that they are well represented in Gleitman. There are texts where it's kind of... Oh, there's one great version where the homunculus is wearing a little towel. I've seen that once. That was cute. Okay, so stimulate here, and the person feels like you're touching them on their skin. if you go around to the right hemisphere, they'd feel the stimulation down the left side of the body. Go to the other side of this, into the frontal lobe, and instead of saying, "Oh, I feel like you're touching my leg," the leg would twitch. Right, yes, left hemisphere, right leg, or you move a little further, the arm would twitch, or just one muscle in the arm, or something like that. Here you've got a motor homunculus laid out across across motor cortex, and this chunk of the brain is important in the generation of voluntary movements. Again, it's a distorted map. Hands very overrepresented. If you're a monkey, feet are very overrepresented. But you who cannot hang upside down from a tree by your feet or your tail or whatever, your feet are comparatively impoverished in their representation. Tongue and vocal apparatus heavily overrepresented. So same sort of story, sensory and motor. Now, these days, you don't even need to go and cut open the skull to do this sort of thing. Transcranial magnetic stimulation, or TMS for short, involves generating a large magnetic field close to the skull. As your physics background will tell you, that generates an electrical field. If you shape the magnetic field right, you can generate an electrical field in the brain tissue, and basically produce the same sort of brain stimulation that Penfield was producing in an open skull, with the same results. Nancy Canwisher, who's a professor in the department here, used to be up at Harvard, got on the front of the Harvard Gazette for teaching her intro class with a TMS stimulator in hand, and said, want to see where my motor cortex is? No, I'm not going to do that. Sorry. The reason I'm not going to do that, by the way, is I'm a chicken. TMS is almost undoubtedly safe. Lots of people do it. But it sounds too much like things that I learned about when I was taking intro psych that were used to generate epileptic foci in, like rats. Let's stimulate, boop, 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 and now the rat's got epilepsy. It doesn't seem to happen in TMS, but I'm a chicken when it comes to my brain. Yes? Could I, yeah, well, we'll find out if I can spell homunculus. Paul, is it a U or an O? Homunc, yes, it must be. Homunculus. One of the reasons for handouts, by the way, is so that when people ask me, can I please spell it, it's on the handout somewhere, because the answer is no, I can't. So the homunculus derived from the Latin for a little man in the head. But I apologize to the women. I was trying to figure out today what the little woman in the head would be, but my Latin has waned since I took it in college. Maybe it's the femunculus. I'm not sure. But in any case, that's the homunculus. The stimulation. That's stimulation techniques. I'm shopping for one more useful technique here. Anybody care to offer me another technique for figuring out what's going on in the brain? The case studies are typically these lesion studies, right? Somebody has something wrong with them, and we try to figure out what's wrong with them. That goes way back, by the way. The early efforts to figure out what bits of brain did come from the phrenologists, early 19th century, phrenology. If you know anything about phrenology, you learned it from the Cartoon Network, right? Because you watched Bugs Bunny beat Elmer Fudd over the head, right? And then the bumps showed up and you felt the bumps. Looking at me like, what's he talking about? Right? Or you know it because there's a wide, any of these umpteen cartoons or sculptures where you have a head that's got little functions all over it. Right? This is, okay, good, I'm not just making up weird stuff. The phrenologists believed that the shape of the skull reflected the underlying shape of the brain, that bigger meant more of that particular function, which is rather like this. I mean, it's not a completely wacko assumption. And they then used a sort of a case study system to try to figure out what different parts of the brain did. So if you wanted to know where criminality was in the brain, you'd go and find yourself some criminals and check where they got big chunks of their brain. And that's where those sort of maps came from. It's a rather ad hoc sounding kind of process now. So amativeness, lust, is typically located back here. The reason it's located back here is because Spurzheim, one of the founders of phrenology, had in his care how did he describe it? I think she's described as a passionate widow. And every time Spurzheim put his hand on the back of her neck, it became red and inflamed, and he therefore concluded that that's where lust lived. It turns out, though, that if you read old phrenology texts, the original phrenology texts, they read not unlike introductory psych texts or introductory brain science texts with a few unfortunate assumptions, like the notion that skull shape reflects underlying brain shape, which it does not very well. There was, yes, pink person. Okay, well that's, so we'll put the, looking at the cells part under the anatomy. My wife would hate this. My wife is a neuroanatomist. That's what she does for a living. She would want many categories for that all by itself. But yes, so you can go look at, certainly as, well, you can use this in a number of contexts. If you're going to go stimulate, these days, if you're going to go stimulate brain cells, you might be doing it on a slice of brain in a dish to see how it's connected to the next one, and you would be looking at the individual cells under a microscope while you were doing that. Yes? Oh, yeah, genetics is another candidate for 5, but I will actually, if you take a look at, that allows me to make a somewhat different point. On the handouts, the writing assignments that you get in this course this year will have as their starting point readings that live on the Stellar website for the course. Oh, they particularly will if I ever give Mara the disk to put them up there. I'll have to remember that. The one that's on for this lecture, if one wanted to write based starting from this lecture, is actually a genetic study. Turns out that there are 2 flavors of vole out there, a little rodent-like animal. Some voles are promiscuous. Some voles are not promiscuous. They just hang out with one. I guess lady voles, that's a basketball team, isn't it? Anyway, I guess they're vols, not voles. Anyway, the claim of a new paper this year is that manipulation of a single gene is able to turn promiscuous voles into faithful voles. So in that sense, yes, absolutely, genetics are a new tool for getting to this. It's not what I'm fishing for. I'll take one more bit of fishing expedition, and then I'll just... All right, that's fine, too. In vole land? Yeah, it's the male voles who are promiscuous. Yeah, I mean, and they're manipulating the sexual behavior of the male voles. The female